Okay, so when graphing the exponential and the logarithmic functions, the A is your vertical stretch, compression, or reflection. The B is the base of the exponential function or the base of the logarithmic function. It is not a transformation. Okay, so the base of the exponential function it is not a transformation. I'm just going to write not a transform because I can't fit it in there. And then this B is the base of the log. And again, not a transformation. So we will have like different parent functions depending on what your base is. You have the y equals 2 to the x parent, the y equals 10 to the x parent. They all have a very similar shape. They're just slightly different. All right, remember the h is going to shift you left or right, so it's your horizontal shift. Horizontal shift. Left or right. And then your K is your vertical shift up or down. Remember that the horizontal shift is the one that's always backwards of what you think. So if it says -5, it actually shifts you to the right 5. Horizontal shift. You can make a note if that helps you.
For horizontal?
Mm-hmm.
And plus as well.
Yes. Mm-hmm. All right, both of these functions have asymptotes. And so I want you to look at the examples on the bottom. At the bottom of the page, you'll see that the exponential function has a horizontal asymptote, and that's that dashed line. Have we studied asymptotes before in this class? Yeah? Okay. So the asymptote type is horizontal. I'm going to write HA for horizontal asymptote. And the equation of the horizontal asymptote is going to be y equals whatever is your k number, because that k number is shifting you up and down. So if it started at 0 and you shift up 5, then that's where your asymptote is. And then the logarithm, you'll see at the bottom of your page, it has a vertical asymptote. All right, and that one is controlled by shifting it left and right. So it's going to be x equals, and the number that shifts you left and right is your h. All right. Horizontal asymptotes and vertical asymptotes, they look alike because you draw them both with the dashed lines, and each function has one, but there's a little bit of a difference between them. A horizontal asymptote is really telling you what's going to happen at the ends of your graph, so it's defining your end behavior, and you'll see that show up when we do end behavior. A vertical asymptote is a value that's just not defined, and you'll never have a value on that. So not with exponentials, but with rational functions that we do later, you can actually cross a horizontal asymptote. Like a function could cross it, but you will never ever cross a vertical asymptote. Not once in your life. All right, so a horizontal asymptote is a horizontal line. And you should draw it dashed. That the graph approaches. As x approaches positive infinity or negative infinity. So for the exponential functions, it's only going to approach the asymptote on one side. Like you can see this one down here is approaching it on the left side. But later when we study rational functions might be approaching the asymptote on both sides. So I'm going to just lift this so we can see the definition and the asymptote at the same time. So this is the horizontal line that the graph is approaching. It's getting very close to it. It never actually touches it though. So it's approaching this line as x approaches positive infinity or negative infinity. So in this case, as x is going to negative infinity, we're approaching the asymptote. The vertical asymptote is a vertical line, also drawn dashed. Also draw it dashed, that the graph approaches but never crosses. Okay. And if you finish writing, I do want you to take a look at the table of values for both your exponential parent and your log parent. And see if you can plot those points on your graph. So what you might want to do for the first problem on the back is start by graphing it on your calculator to get an idea of what the shape is. Okay, may I start? All right, so over here we have an exponential function. And an exponential function has what kind of asymptote? Yep, horizontal. So I'm just going to remind myself it's going to have a horizontal asymptote. I just put an H down here just to remember that. I can do the transformations even without looking at the graph because remember the 10 is the base, that's not a transformation. The -3 is the tricky one. It shifts you which way? To the right. Because we would think to the left, right? But it's to the right. So under here for transformations, I'm going to write shift right 3. And then the -2 shifts which way? Down, yeah. Shift down 2. And that's it, because the 10 is the base. That's not a transformation. All right, so even if I didn't have a graphing calculator, I could take the points from my parent function here, and I could shift them right 3 and down 2, and I would have my new graph. All right, so that's very possible. It would involve a little bit of flipping, but that's fair. That's not a problem. My horizontal asymptote was at y = 0, and it shifted down 2. So even without the calculator, I know my horizontal asymptote is y = -2. And the asymptote won't show up on your calculator either. So you do need to know how to figure out where the asymptote is. And for an exponential, if it shifts up, that's where it is. If it shifts down, that's where it is. Okay, so I'm going to start by drawing my horizontal asymptote at y = -2 with that dashed line. And then I'm going to the calculator. All right, on the calculator, I want you to put in the function 10 to the x - 3 and then -2. Remember, press y = first. And then My IB students may have used these calculators and messed up the, actually, you know what, before we even do this, let's just clear the memory. All right? Because we're gonna have, they have weird windows that they use in the IB math class, so let's restart. Let's second quit out of that. Okay? So quit out of your y equals, and then we're gonna clear your memory. Second plus 7, 1, 2. And we'll go back into our y equals, and we're going to enter the function 10 to the x minus 3 and then minus 2. All right, and I got that from my paper, so you don't need to look at my screen, just get that from the paper, okay? Anybody need help finding the y equals? All right, check with your neighbor if you're having trouble, and then we're going to press graph. And we should have a graph like that.
Mine?
I know mine is.
So you have a negative 3 instead of a minus 3 up here. So just change it to a minus 3, okay? Anything else, guys? Any questions so far?
The asymptote's -2, right?
Y equals -2, yeah. So remember for your asymptote to write that whole equation, y equals -2. All right, so we know that it's going to look a little bit like that, and so we want to get that shape on our paper, but we don't want to just sketch any old shape. So we need some numbers. Remember we had a table of values over here? So we want a table of values. So you're going to look above the graph to the table, press second table. Who wants to hear that again? Press second, and then graph, which has table above it. All right, notice that if you scroll back in these numbers, see how it thinks, your calculator thinks it's going to get to -2 because that's how it's rounding. But it never actually does get to -2. This one is really like -1.9999 and then -1.9999. So it's just getting closer and closer to -2. We don't need these numbers because I'm not really good at graphing -1.9999. So I might use 2, 3, and 4 as the numbers I'm going to put in. Okay? Good morning. Grab a calculator. 2, 3, and 4. So on my paper over here, at the top, I'm going to write X and Y. And I'm going to start with 2, 3, and 4. I chose those numbers because they fit on my graph. So see, 598 is not going to fit on my graph. And also, I feel like I could get pretty close to graphing -1.9. This -1.99, I just don't think I could graph that. Okay? So then I'm going to graph -1.9, -1, and 8.
Is this stuff going to be on the quiz?
Mm-hmm.
It's next class?
Yeah. All right, so let's graph those. 2, -1.9. 3, -1. And 4, 8. 2, 4, 6, 8. And then remember the way the shape goes, it doesn't just stop here, it continues going, so it looks like it's really like leveling out on that line. What's really happening is it's getting closer and closer to that line, but it's impossible to draw that, so you just do your best. Here's my graph. It kind of looks like an L shape, but I want you to know though, that it does continue getting closer to the 2 on the left, and then on the right side it does continue going out in addition to going up. So we're going to do domain. You can see that your domain starts on the left at -infinity. It's a little tricky to see that it keeps going to the right, but it does keep going to the right, so your domain is -infinity to infinity. Oops, you can't see that. Okay, your range does not start at negative infinity. Because of the horizontal asymptote, that's holding the whole graph above the -2. So your range starts right after -2. I know your calculator says that you're going to hit -2, but you're not. That's just your calculator is rounding error. You're getting really, really close to -2 without ever touching it. So your range starts right after -2. That's why I use the parentheses. And then it continues going up to infinity. Okay, the x-intercept is going to be the hardest thing to find, so I'm going to do that last. We're going to do the y-intercept. For the y-intercept, the x value is 0. So I'm going to go to the table to find that. So go back to your calculator, and looking at your table, I can see it's 0, negative 1.999.
Wait, why is it 0?
So on the y-axis, the x is always 0. We're going to come back to do the x-intercept. We're going to do the end behavior. Okay, as x goes to infinity, the y is going to infinity. And then as x goes to negative infinity, the y is going down, but it's not going to go to negative infinity because it's stuck above this asymptote. So the y is approaching -2. All right, for an exponential function, one of your end behaviors will always be the asymptote.
For one of them?
Yeah, because the other side will be going up or down. All right, make sure you have this because we're going to do the x-intercept and we're going to do it on the calculator and you're going to need to be focused on that. So make sure you're good with this. Yes? Which bracket? On the -2? So the reason we use the parentheses is because we never ever hit -2. So the parentheses means not including -2, but get as close as you can to it. Okay, so I'm going to my calculator to find the x-intercept. So you should pick up your calculator. Press graph. So looking at the graph, it looks like your x-intercept is 1, 2, 3, 3 point something, right? It's right here. My record back on. What you're going to do is you're going to calculate the x-intercept. So look up here above trace. This is where the calculate is. So we press second trace. Press second trace. The x-intercept is also called the 0 of the function. So we're going to be finding the 0. So second trace and then choose 2 for 0. It's asking for the left bound. Do you see that at the bottom of your screen? It says left bound. We want to move the cursor so that it is just to the left of the 0. Remember, this is the number we're looking for. It doesn't have to be like so precise that it's exactly to the left of it, but we just get a little closer. Okay? So you can see where my cursor is now, right here. That's a decent location. So for left bound, I'm moving my cursor using this arrows here. And then I press enter 1 time. After I press enter 1 time, it asks for the right bound, and so we use the right arrow until you're to the right of that 0. So you can see where my cursor is. That's a good place. And then press enter 1 time. I know your calculator doesn't give you those nice lines. It's fine. And now it says guess. It wants you to move close to the 0 and press enter 1 time. All right, now if you did all those steps correctly, you should have 3.301. And so we're going to put this on our paper for our x-intercept. We'll have another chance to try that if you didn't get it that time. It was 3.301, 0. What questions do you have on this one? Okay, we're going to graph number 2. So if you're ready, press y equals and graph problem 2.
Can we put in the first one?
Yep. All right, we're graphing number 2. We can take a look at the shape on your calculator. Y equals clear log x plus 2 plus 3. Okay, take a look at that shape. You see how it looks a little bit different from the log that's on the front of your paper? It like looks more cut off. Your calculator has a real issue with finding those values that get really close to your asymptote. And so it just doesn't even graph them, which makes it difficult for finding your x-intercept here because it's not graphed. The graph doesn't end, it keeps going down, okay? This is going to be tricky. This calculator is not going to be as useful for finding that number on the graph, but we will be able to find it algebraically, and I'll show you how, okay? All right. So let's go back and put down our transformations and our asymptote. The plus 2 shifted you which way? Is it left or right? Left, yeah. So the plus 2 is going to transform us left 2. And then the plus 3, which way? It is up, yeah. Up 3. Okay. Your parent function had a vertical asymptote at x equals 0, but it shifted left 2. So you need to move your vertical asymptote left 2. Remember, a logarithm has a vertical asymptote. When we move it left 2, it ends up at x equals -2. All right. We need a table of values so that we can graph some points here. So let me start that over here. And then we're going to look at the table on your calculator. So pull up your calculator. And then second graph gets you the table. So you see how we have error here? It's because your calculator, this is where your asymptote is, so there's nothing there. So I can use the -1, 3. I can use the 8, 4. And then you can just pick any of the ones in the middle here. I might choose 2, 3.6. I hit second graph.
No, yeah, but like mine doesn't have -2 and -6.
Oh, you just go up, yeah. Okay, so I chose those because they were integers, and then you can choose one of the ones in the middle, like 2, 3.6. Okay, even though the calculator looked like it stopped, you know it keeps going, so you have to draw your shape there. All right, so this time it's our domain that is not -infinity to infinity because we have this vertical asymptote that's stopping our graph. So our graph starts right after -2, and it keeps going to the right to infinity. Your range is from the bottom, which is -infinity, and then up to infinity. We're going to find your y-intercept on your table of values. So go back to your table of values and look and see when x is 0, what is the y? Anybody find it yet? Second graph, look at your table. All right, so I'm gonna look at the table. It says 0, 3.301. So that is my y-intercept. I won't be able to find the x-intercept the way I found it before because the graph stops, and so it's not gonna help me calculate that. So I'm gonna show you how to find that by hand. And now we're gonna do your end behavior. As x goes to infinity, y still is going up slightly, so y is going to infinity. X can't go to negative infinity because of the asymptote stopping it, so the other one is as x goes to -2. And as x goes to -2, y is going to infinity. Negative infinity, sorry, it's going down. All right, I'm gonna show you how to find that y-intercept. Oh, sorry, the x-intercept. What's that? Oh yeah, I'm sorry. If you are interested in knowing how to find this intercept when you can't see it on the graph, you might need a piece of paper because there's not really room to write this on your paper. The back of your packet is blank, so you could use the back of your packet. All right. When we find our x-intercept, your y value is 0. So I set the y of the function equal to 0. I isolated the log by subtracting the 3. And then I exponentiated both sides. So I made both sides base 10. And then I solved for x. So you guys actually have been solving problems like this already. You probably just didn't realize that that's the step you would take to find your x-intercept. So then once I do that, then I know my x-intercept is negative 1.999, comma 0. Yes? Oh, the y-intercept is 0, comma 3.301, and I found that one on the table of values. Questions? Oh, it was 10 to the -3, and so if you put that in your calculator and you press math fraction, you'll get 1/1000. All right, we'll do one more together, and then we're gonna do one on the whiteboards, and then we'll have some time to review for your quiz. So we're gonna do number 3 next. So if you're ready, you can move on to number 3.
Wait, and this is how you find what?
This is how I found the x-intercept when it didn't show up on the graph. So your graphing calculator kind of has an issue with when we get really close to your vertical asymptote. And so that makes it look like the graph stops, but it doesn't stop.
Okay.
All right, I'm moving on to 3. Okay? All right, so the transformations, you have an x plus 1. That one shifts you which direction? So remember, it's the tricky one because you want to say right, but it's actually backwards. It's left. Left. So we're going to shift left 1. And -5 shifts you which way? Down. So shift down 5. The 4 is not a transformation. That is the base. But the 2 is a transformation. What does the 2 do? Drew says stretch it. Anybody agree? Yeah, good. So remember that number in front could be a vertical stretch, a vertical compression, or a reflection. But because it's a number bigger than 1, that's a stretch. So vertical stretch of 2. Okay. So the shift down 5 will shift your asymptote down 5. So it's going to be y equals -5. And now I'd like to look at the shape of the graph on the calculator. So press your y equals and enter your equation. Let's look at the shape. Okay, so this is my shape. So I'm going to sketch it in. There we go. So now we have the information we need to answer the questions. Domain, -infinity to what? Positive infinity. My range does not start at -infinity because I have this asymptote at -5. So my range starts right after the asymptote and goes up to infinity. The y-intercept, I'm going to get that on my calculator. Give me 0, comma, let's take a look. It's 3? Nice. 0, 3. We'll do the x-intercept last. Let's do your end behavior. End behavior. As x goes to infinity, what does y go to? Infinity, good. And as x goes to -infinity, take a look at the picture. As x goes to -infinity, it's getting closer and closer to what number? -5, right, the asymptote. So the y goes to -5. So we still have to go back and find our x-intercept. These are the steps. Some of you missed it the first time, so make sure you're caught up and then pick up your calculator again so we can find our x-intercept on the calculator. You should have this equation entered in your calculator. So look at your calculator. Did you press your y equals and get your equation put in yet? Y equals, good, get that in there. And then we're gonna look at the graph together. So let's do that now. Here's the graph. So it looks like it might be about -0.2, but we're gonna find a better estimate for it. Hold your calculator. I'm still waiting for some people to hold their calculator. Okay, so you already have the equation in. The next step is second trace, because we are going to calculate the 0 of the function. 0 is choice 2. I need to move the cursor to the left of the 0, so I need to use the left arrow. That's fine right there. Press enter once. Use the right arrow, move to the right of the 0. Actually, that's way too far. That's fine right there. Press enter. And then for guess, just move close to it and press enter. So I'm getting -0.339. Anybody else get that? Does anybody want to see it one more time? All right, so you have the graph, right? Okay. So when you have the graph, I'm going to go back to graph. And you do second trace. We're trying to find the 0 of the function. That's choice 2, so press 2. And then for left bound, use the left arrow to go so that you're to the left of the 0 and press enter. Then it says right bound, move to the right of the 0 and press enter. And then for guess, move close to the 0 and press enter. So we're going to put this on your paper now. -0.339. 339, comma 0. All right, the fourth one will be in Schoology if you want to see another example, but we're not going to do that one right now.